Hello, everybody. So you guys asked for me to make a video. I'm going to try to do this as much as I can for the practice assignments. So feel free to fast forward or if you need to. And I'm going to go through these one by one. So if you can't get a hold of me, then you can still see how I did a lot of these problems. I'm going to use all the algebraic properties that we know. Okay, I'm going to break down these limits into their most basic pieces and then evaluate them. So I'm going to start with the limit as x approaches 3 of, now because I have a coefficient, I can take a 2 out front of f of x plus the limit as x approaches 3 of g of negative x. Now, I cannot take that negative outside of the g, so that's got to stay there. I can only take it out if it's a coefficient in front of the function, not in front of the argument. So if I do this, 2 times the limit as x approaches 3 of f of x from the table above is 4. And then now if I take the limit as x approaches 3 of this, if I do a direct substitution, I'm going to get g of negative 3, which in this case would get closer and closer to the value of 5. So if I did 8 plus 5, I get 13 to be my answer. Okay. So number 2, I do the same way. Whenever I have a quotient, I'm going to split that quotient up into the numerator and denominator. So I'm going to take the limit as x approaches negative 3 of g of x all over the limit as x approaches negative 3 of f of negative x. And if I evaluate this at negative 3 for the numerator for g, we know that's going to be 5. And if I evaluate on the bottom f of a negative x, if I plug negative 3 into that, that's actually going to give me a positive 3, which would be 4. So I would get an answer of 5/4. Okay. Keep going. I have 2 more that are very similar. So I'll just practice. I'm going to split this up. Sorry about that. I'm going to say the limit as x approaches 2 of f of 2x minus the limit as x approaches 2 of f of x over 2. And if I plug 2 into this, to the first limit, I'm really going to get kind of the limit as x approaches 4. So that's going to be 2. And if I plug 2 into the next one, it really turns into limit as f approaches 1, which would be a 6. So 2 minus 6 is a negative 4. Keep going. I have another quotient here. So I'm going to say the limit as x approaches 2 of f of x over 2 all over the limit as x approaches 2 of f of a negative x. So if I do this, the upper limit is going to approach as x approaches 1, so the whole function will approach 6. And if as x approaches 2, if I substitute that in, it's really as x is going to go to negative 2, so that's going to be a negative 3, and we can reduce that to be a negative 2. Okay? All right, so now I have some compositions. So we're going to do this kind of one by one. I'm going to do the limit as x approaches 3 of f of x is going to be the same thing as the limit as x approaches. Now, as I go to 3, from the left and from the right, I'm going to the value of negative 1 of now just f of x. And if I approach negative 1, again, this is a two-sided limit from the left and from the right. that is going to give me a value of 3. Okay? Same idea. So we're going to do the limit as x approaches 1 of f of x, which will then turn into the limit as x approaches. Now, if I go to 1 on f, we already said, oh, we didn't do that one yet. Let me erase all the other arrows that are on here. And as I go to 1, I'm going to this hole at -5 of f of x. And if I do that at -5, again, the two-sided limit, that is going to be a value of 2. Okay. I think I have one more. Yeah, so we have one of g. So a new graph. So I'm going to do this the same way. So the limit as x approaches 2 of g of x is equal to the limit as x approaches. Now, as I go to 2, I am going to the value of 0. Now, do you also notice how that is a minimum? Because it is a minimum, both the left and the right side are approaching 0 from the positive side. So in this case, I'm going to put a little positive there, all right, of g of x. Now, as I approach 0 from the positive side, that's going to give me an output. Get my stylus working here. Hang on. Of 2. Okay. Now, I kind of answered the question for number 8. Using the graph of g, which of the following is equivalent? If you notice the way that I rewrote it, 0 from the right would be C. Okay. All right, so we're going to use the information to evaluate these limit expressions. So I'm going to say I have the limit as x approaches 1 of f of x, and then we can square that, minus the limit as x approaches 1 of h of x, and then we're just going to subtract g of 1 at the end. So we're going to use the information from the table. So as x approaches 1 of f is -1 squared, minus h as x approaches 1 is 6, minus g of 1 is a -2. Be careful with your negatives here. So I have 1 minus 6 plus 2, which will give me 1 minus 6 is a -5, plus 2 is a -3. Okay. Same idea. F of 1 is 4, plus, I'm going to take the negative out as x approaches 1 of g of x. So I have a negative times as g approaches 1, so that's going to be a 3, which will give me an answer of 1. Okay, and that concludes the practice for 1.5. Hopefully that helped. Let me know if you have any further questions.